Hey guys, in this lesson we would understand how to solve word problems for rational and polynomial functions. So we will be taking a few examples of rational and polynomial function applications. Let's read the first question. The question says an open-topped box can be created by cutting congruent squares from each of the four corners of a piece of cardboard that has dimensions of 20 cm by 30 cm. Determine the dimensions of the squares that must be cut to create a box with a volume of 1008 centimeters cubed. So there is a piece of cardboard that has dimensions 20 by 30. This is in centimeters. After we cut four congruent corner squares, we would be left with this green colored shape of the cardboard. When we fold this cardboard around these imaginary lines, we would be able to turn it into an open-topped box. And this is how the box is going to look like. Now the dimensions of this box, for which we are given the volume, because they have mentioned that a box is created with a volume of 1008 centimeter cube. So volume of this box is equal to 1008 centimeter cube. We know this box represents a rectangle base prism, and volume of rectangle base prism is represented with length times width times height. Length of this box would be 30 minus the two corner lengths of the congruent square. So let's say each side of the congruent square is an x. As the original length of the cardboard was 30, we take away from 30 2x, and the result would be the length of the box. Therefore, this length of the box would be represented with 30 minus 2x. Now this is the width of the box, because here also this whole length was 20, and since the squares are congruent, their sides are all going to be same. So this is also x and x here. As a result, this green length would be 20 minus 2x. So now we got the length, we got the width, we are only left with the height. We notice that this box is folded across this line, and this line is nothing but parallel to the side x. Therefore, this height is going to be represented with x. Now we've got all the dimensions of this box, and we also know the volume of the box is length times width times height. We will sub in the length as 30 minus 2x, width is 20 minus 2x, and height we know is x. Volume we know is 1008. We need to find out the dimensions of the squares that must be cut. So technically we are looking for the x value. And we notice here that in the equation, the variable that we have is the x. So if we solve this equation, we would be able to find out the value of x. We also know that if we want to solve a polynomial equation, then the other side of the equal to sign should be a 0, which is not equal to 0 in this case. So in order to make it a 0, we would first move this on the other side. When we move it on the other side, this side becomes a 0. So we would be left with 30 minus 2x times 20 minus 2x times x. This whole thing is one term minus 1008. The reason this whole thing is one term is because this whole thing is connected to each other with a multiplication sign. Now first what we have to do is we would have to expand this all, collect this 1008 with the rest of the term, and then solve for x. So let's first expand these. We would be able to get 30 times 20 is 600. 30 times minus 2x is negative 60x. Negative 2x times 20 is negative 40x. 2x multiplied by 2x is going to be a positive 4x squared. This whole thing would be written with the product of x minus 1008. Now we would expand this all with x, and we would be left with 600x minus 60x squared minus 40x squared plus 4x cubed minus 1008. Let's collect all the like terms and arrange it in the decreasing order of the powers of variable. So 4x cubed, this and this together is going to give us 100x squared plus 600x minus 1008. Now we see that we have a polynomial expression that is equal to 0. So if we want to solve for a cubic polynomial function, then we have to undergo factoring first, because this is not in factored form. Now when we factor this cubic polynomial function, we see that 4 is going to be a common factor for each of these terms. So we can factor 4 out. We'll be left with x cubed minus 25x squared plus 150x minus 252. 0 divided by 4 would give us a 0. We can take this 4 on the other side, such that we would be left with x cubed minus 25x squared plus 150x minus 252 would be equal to 0. Now we have to look for the factors of negative 252 in order to apply factor theorem to this function and to further factor it. When we use all the factors, then we notice that x equal to 3 when we sub into the function would give us a 0 value for the function. So we can write down when x is equal to 3, the function fx would be equal to 0. Therefore, x minus 3 will be the first factor of this polynomial function. To find out the rest of the factors, we can do synthetic division. Here the number is 1, negative 25, 150, negative 252, and here goes 3. The first number comes down as is. 3 times 1 is 3. We get a negative 22. 3 times negative 22 is a negative 66. When we add it, we would be able to get an 84. 3 times 84 would give us a positive 252, and that would be equal to a 0. Therefore, the other factor of this function would be 1x squared minus 22x plus 84. Now this whole equation can be written as 0 equal to x minus 3 times x squared minus 22x plus 84. To get two factors out of this quadratic equation, we would have to use quadratic formula because this equation is not factorable. Therefore, we will be using negative b plus minus square root of b squared minus 4ac over 2a. And here b, a, and c would be taken up from here. A is 1, b is negative 22, and c is plus 84. We will be left with 22 plus minus square root of 22, which is negative square, minus 4. A is 1, C is 84, over 2A, which is 1 again. When we solve this, we would be able to get 22 plus minus square root of 148 divided by 2, and this would give us two factors. One we would get by adding 22 to 12.17, that is the square root of 148 divided by 2, and the other we would get is by subtracting 22 and 12.17, whole thing divided by 2. The result would be 17.08 and 4.92. Therefore, the two x-intercepts or two roots that we get from the quadratic formula is this, that we can write down in the factored form as 0 equal to x minus 3. In bracket we have x minus 17.08 and x minus 4.92. Now all of these factors are equal to 0 since they are product of each other. So we can write on each of the factor equal to 0 to solve for x. So first x value we have is 3. Next is x minus 17.08 equal to 0 means x is equal to 17.08. The third factor is x minus 4.92 equal to 0. That would give us x equal to 4.92. This is how we get three x values from the cubic polynomial function. Now the demand of the question was to determine the dimensions of the squares that must be cut. So we were looking for the x value that will hold true for this box. Now remember, this x value is not just involved for height, but it is also involved for length and the width of the box. So we would have to pick the right x value such that the length and the width of the box can also be defined. We know length is 30 minus 2x and width is 20 minus 2x and height is x. So any of these x values can hold true for height. However, for length and the width, because we have to take away from 30 to x, so if we try take away from 30 2 times 3, so if x is 3, 2 times 3 is 6, we can subtract it from 30. Similarly, if x is 3, 2 times 3 is 6, we can subtract it from 20. So x equal to 3 holds true for each of the length, width, and height. So this is definitely one of the x values that the squares can be cut with the dimension. However, 17.08 cannot be an x value because when we multiply 17.08 with 2, we get approximately 34, and we cannot take away 34 from 30 because then we get a negative length and negative width, which is not possible. Let's check 4.92. 4.92 is, let's take it as approximately 5. 2 times 5 is 10. 30 minus 10 is possible. Similarly, 20 minus 10 is possible. So this x value dimension is also possible for the congruent squares. Therefore, the possible values of x are 3 and 4.92. And these two are the solutions for this question. Let's go over the next question. The question says, when they work together, Stuart and Lucy can deliver flyers to all the homes in the neighborhood in 42 minutes. When Lucy works alone, she can finish the deliveries in 13 minutes less time than Stuart can when he works alone. Determine the time that Stuart takes to deliver the flyers when he works alone. Since we are looking for the time that Stuart takes, so let's assume the time Stuart takes is x minutes to finish all the deliveries, as Lucy takes 13 minutes less than Stuart, so Lucy's time would be x minus 13 minutes. We also know that Stuart and Lucy together would take 42 minutes. So Stuart and Lucy's time together will be 42 minutes. Now to form an equation, because that is required in order to solve this question, we have to find out how much work is done by each of them, Stuart alone, Lucy alone, and Stuart and Lucy together in 1 minute. Because whenever we write on an equation, the left side and the right side should describe the same thing. So let's see how to get to their 1 minute work. Now this is for Stuart. Stuart in x minutes completes his task. So he finishes one full work in x minutes. In 1 minute, the amount of work that will be done by Stuart would be 1 by x work. So this is Stuart's 1 minute work. Similarly, for Lucy, 1 minute work would be equal to 1 divided by x minus 13. And in the same way, Stuart and Lucy's work together in 1 minute would be equal to 1 over 42. Now for all of these three cases, Stuart alone, Lucy alone, and Stuart and Lucy together, we have got their 1 minute work values. Now to write an equation, we would take 1 minute work of Stuart added to 1 minute work of Lucy would be equal to 1 minute work of Stuart and Lucy together. Once we get this equation, we are looking for x value because x is the amount of time Stuart takes to finish the work. So in order to solve for x, because this is a rational expression, or we can say this is a rational equation, we'll bring everything on one side so that we get this whole thing equal to 0. Then we'll make the denominators common and we would get the equation like this. The common denominator we can put together 42x, x minus 13, and on the numerator here we have 42x minus 42 times negative 13 is minus 546 plus 42x minus x squared plus 13x. We can move this all on the other side so that this denominator is gone and we would be left with negative x squared plus 84 plus 13x, which is 97x, minus 546 would be equal to 0. And when we solve this equation, finally we would be able to get x minus 91 and x minus 6 is equal to 0, from where we would be able to get x is equal to either 91 minutes or 6 minutes. Now we want to find out of x equal to 91 minutes and 6 minutes, which one is the right pick or which one is the right answer. So what we would be doing is we would be using 91 as x and substitute 91 in this equation. So we would see if left side is equal to right side with 91 as x or with 6 as x. If we put 91 as x in the equation, we would be left with 1 over 91 plus 1 over 78. When we solve this, we would be able to get 169 over 7098, which when we reduce down to lowest terms would be equal to 1 over 42. Since 91 minutes give us left side equal to right side, therefore x equal to 91 is the right pick for the answer and 6 minutes would be ruled out.